Hello, my name is Touraj Ebrahimi. I am senior Java developer. I want to present microservice architecture in talking about differences between a monolithic architecture and microservices, also service-oriented architecture. First of all, I start talking about monolithic application a little bit. As we know, monolithic applications has three main parts. One of them is database part, consisting of many tables. For example, it can be traditional databases, RDBMS like Oracle, MySQL, Postgres, and etc. Also, NoSQL databases like MongoDB, Cassandra, Solr, Elasticsearch, and any kind of database. And the other part of the monolithic applications is the user interface. So something like GUI, graphical user interface, UI, UX, and that can be built using JavaScript, jQuery, HTML, HTML5, and something new like semantic UI or bootstrap. So this is the user interface part. And another important part of the monolithic system that is the heart of the system in the architecture is the server side, the backend. So the business capability of the system resides in the server side. For example, using Spring MVC, we have model view controller, and the controller is responsible for the business capabilities of the system that can be used as a bridge between the user interface as a view and the model that can be connected to the database like MySQL. This is monolithic architecture that I talked about in the previous slide. So in the middle you see HTML, JavaScript, MVC, architecture, services, data access. This is a slide is from Pivotal, my favorite company that has developed a Spring framework, a Spring products like a Spring Boot, a Spring Cloud, Spring MVC, Spring Data, and many others. So, what is a microservice? The microservice architecture style is developing a single application as a suite of small services. So, we, for example, we have a traditional monolithic system and we want to migrate to a microservice architecture. We divide our business, our system into small services instead of having all the capabilities around the business capabilities in a monolithic in a single application. For example, in a monolithic system we have order, recommendation, membership all in one place in a monolithic application. But in a microservice architecture, we have a service responsible for order, another service responsible for membership, and another one responsible for recommendation. So these services are built around the business capabilities And another important issue is that they are independently deployable and can be deployed automatically in an automated way. Most important features of microservices are services are independently deployable. You can deploy every services independent from other services. For example, you can deploy order service in a separate machine, in a Docker container, and membership service in a separate machine, even in a separate data center and in another, for example, Docker container. And also services are independently scalable. So we can scale up, scale down each service independent from another services. For this purpose, you can use Docker containers, Kubernetes, and also Docker Swarm for having scalability. And also another feature is lightweight containers. For example, you can have a container, Docker container for order service, another Docker container for recommendation, another one for user feedback, another one for membership, and so on, like the system that Amazon has. Another important feature is polyglot programming environment. We can design and implement a system using Java language, another system using .NET, another one using Golang, another one using Python, and another one, for example, using Ruby on Rails. So you are not limited to a specific language. You can design each services with a different kind of language. And another very important issue is the security. You can use OAuth 2, JWT, JSON Web Token, and if you use an API gateway, you can implement security in the layer of API gateway. For example, Netflix has a very good API gateway. In another part of the presentation, may I talk more about API gateway and what is it and what is the capabilities and usage of API gateway. And another feature is mediation and intelligent routing. For example, Spring Cloud has a product framework, we call it ZWL, ZWL, that can be used for intelligent and programmable routing. Another capability is hot swap ability, and the end we have monitoring and manageability. For example, for monitoring microservices, you can use an ecosystem that has been built using, for example, some kind of time series database like Prometheus or InfluxDB, and a graphing tool for monitoring, for example, Grafana, and also using JMX and JMX exporter, JMX collectors. So with this kind of technologies, Prometheus or InfluxDB, Grafana, and Docker, JMX, we can design a very good monitoring system. And in this slide, uh, you can see that the green curve is monolithic system that evolving during the time from low complexity to a very high complexity, and the blue curve is microservices. So this slide simply tells you that when you have a simple system, if you use monolithic design approach or architecture, you will have better productivity rather than using microservices, because when you want to design a simple system, not a very complex one, if you go for microservice design, you will add extra complexity that is not necessary. And whenever the complexity of your system increases, the monolithic approach will be reduced from the perspective of productivity, and the productivity of the microservice architecture will be increased. So the decreased coupling of microservices reduces the attenuation of productivity. And also another important note that I have written at the bottom of this slide is, remember, always remember, the skills of the team will outweigh any monolithic or microservice choices. So if in your team you don't have enough knowledge, enough profession, and very expert or good developer that are familiar with microservices, I mean, have experience with microservices, it's not suggested that you go for microservice architecture and design. It would be better for you that you choose a monolithic architecture. In this slide, I'm talking about cons and pros of a microservice architecture. I think I have screen captured this slide from Martin Fowler site, my favorite scientist, Martin Fowler, that has many good articles regarding designing patterns and computer science, microservices, SOA, and many good articles regarding different aspects of development, programming, and enterprise integration patterns. I think this slide is from Martin Fowler. So one of the cons, excuse me, I start with pros. One of the pros of the microservice architecture is strong module boundaries. So when you design a microservice architecture, you should adhere to bounded context of the system. Bounded context is should be designed around the business capabilities of the system. For example, when you are using domain-driven design, it shouldn't have a service per table. For example, if you have order table, relation between order to membership, order queries, order amounts, etc. So bunch of tables that are around the business capabilities of the system that can be aggregated into a bounded context will be used and will construct a module boundaries. So microservices reinforce modular structures. That is very important issue for large teams. Another pros of microservice architecture is that each service is independently deployable. So when you design microservice architecture with simple enough simple services, each of them are easily deployable and also autonomous. So when one of the services fail, the whole system will continue working, and you give this influence, this feel to the user that always the system is up and working. For this regard, you can use interpret integration pattern. For example, one of them that is very important and very popular in microservices is circuit breaker. I will talk about it in another part of the presentation. Another pros of the microservice architecture is technology diversity. I talked about it in previous slide. You can have a polyglot programming approach. You can design each microservice with a specific language. For example, one of the microservices can be designed with Java, another one with .NET, another one with Golang. And also, in database layer, or it would be better that I say each database for each microservices can be selected independently. For example, one microservice can use MySQL database, another one can use Elasticsearch, and another one can use MongoDB. So based on the capabilities and the requirements and the responsibility of each microservice, try to choose a good database that fit that the purpose of that microservice. For example, if your service is responsible for user search, it would be better that you use Elasticsearch or Solr. Both of them are based on Lucene from Apache. And if you have a service that has many transactions, you want to use transaction capabilities, it would be better that you use some kind of RDBMS, for example, MySQL, PostgreSQL, or Oracle, or SQL Server. And if your service is something that would be better, you use NoSQL databases, for example, MongoDB, Cassandra. So go for it. So based on the capability and the requirement and the purpose of your service, use a good and a related database. So what are the cons of microservices architecture? One of the problems is related to distribution, because distributed systems are harder to program for developers, and also they add more single point of failure in comparison to a monolithic system. Also, they add more latency, because in a monolithic system we don't have any kind of latency because all the system in one place in a single project, for example, single WAR file, single jar file, all hold the system in one place. So you don't have any communications between different services. But when you use microservice architecture, you will have more latency and also the risk of failure because of not for example, maybe you can communicate between services sometimes from one server to another server, from one Docker container to another Docker container. Sometimes one service may be down and you don't have access to them. So this is related to distribution problem of microservice architecture. Another problem, another cons of the microservice architecture is eventual consistency. In monolithic system, in traditional transactional system, you have strong consistency. You have immediate consistency based on ACID principle. ACID means atomicity, isolation, durability, and availability. But in microservice architecture, based on Eric Brewer suggestion and articles, you should use base approach, BASE. That is the abbreviation of basically available, soft state, and eventual consistency. I will talk about base, acid, and also captorium that has been devised. Captorium has been devised by Eric Brewer in another part of the presentation. So I will go back to eventual consistency, acid, base, and cap in another part. Another problem in microservices architecture is operational complexity. It adds more overhead for DevOps teams, more complexity for the operation team because they should manage a lot of services in comparison to a monolithic system that basically you have, for example, only one service, everything in one place. They should manage a lot of services in different servers, different machines, even different Docker containers. So it's very huge amount of work for operation team, and they should redeploy each service on a regular basis. Okay, in this slide you can see easily differences between monolithic system, service-oriented architecture, and microservices architecture at a glance. So, monolithic system is single unit, all things in one place. In SOA architecture, you will divide monolithic to some services. That is a coarse-grained architecture. But in microservice architecture, you divide it to more microservices. We call it fine-grained. In this case, we have an anti-pattern called nanoservices that you can divide monolithic system to a very fine-grained services. We call it nanoservices. It is not suggested, and it is an anti-pattern. So keep in mind that it's not a very good approach if you divide monolithic system to a microservice system blindly, and so at the end you may have many unrelated services. In a nutshell, microservice architecture is fine-grained and SOA is coarse-grained. Monolithic is single-unit. In this slide, you see microservice architecture suggested by Pivotal. In this part, we have some kind of API gateway, for example, and different kind of clients that using this API gateway in order to communicate with the infrastructure of our architecture. So we may have different kind of clients, for example mobile client, desktop applications using browsers like Firefox and Google Chrome, and mobile applications, mobile clients may use Android platform or iOS platform in order to communicate with our microservice environment. Also, third-party applications, other systems that may use different kind of protocols for accessing our infrastructure and our microservices. All of them has a single point of entry for access to our infrastructure. We call it the API gateway. The API gateway, according to enterprise integration pattern, is responsible for translating and transforming different kind of protocols into a single language. So different kind of protocols can talk to each other as a single language. For example, we may have a client that uses HTTP protocol for communication, and also our microservices use HTTP for communicating with the API gateway. Another microservice may use some kind of protocol like AMQP. AMQP stands for Advanced Message Queue Protocol. For example, ActiveMQ and RabbitMQ support this kind of protocol. We have other similar protocols like MQTT, that stands for Message Queue Telemetry Transport. Also, ActiveMQ support and MQTT. MQTT is a very good protocol for using in IoT, Internet of Things, because it's a lightweight protocol rather than using AMQP that is a very it has more overhead than MQTT that is considered as a lightweight protocol. Or we have another kind of protocol, we call it STOMP, stamp. Simple, it stands for simple or streaming text oriented message protocol. It's very lighted. It's text oriented. For example, you can even use a telnet client to connect to a stamp server. And RabbitMQ, excuse me, ActiveMQ support stamp also. Basically, ActiveMQ support different kind of protocols like AMQP, as I told, MQTT, stamp, and OpenWire. But other kind of messaging systems like Kafka may have their own protocols. Kafka doesn't support these kind of protocols like AMQP, MQTT. Kafka has its own protocol that is called Kafka topics. In this slide, each hexagon represents a service, and as you see, each service is also redundant. For example, you have two orange services that basically are one service. For example, or service, or excuse me, order service. You can have redundant order services that will be beneficiary in case of failure. In this case, you have, for example, two redundant order service in a single machine, in, for example, two Docker containers, or in different machines, in different servers. And also, for example, here you have three redundant, for example, membership services. Each of them has its own database. For example, the Orange service has relational database, RDBMS, for example, MySQL, and the Gray service has a key value store as a database. For example, Redis or Redis Sentinel, if you want to have clustering feature, you can have Redis Sentinel or other key value stores like etcd from CoreOS, Spike, Apache Giat, and other kind of key value stores. And here you have a service that uses AMQP protocol. For example, here you may have message broker like ActiveMQ and RabbitMQ. This message broker publishes events to subscribers, the services here that you have redundant services. For example, maybe a credit system here, or a social networking system that use a GraphDB like Neo4j. Okay, and this slide is a Gartner view of a microservice, inner architecture, and outer architecture. Similar to the previous slide, you have different kind of clients. Here, for example, mobile client, desktop application, third party, and cloud applications that this client communicate with our microservice environment using API gateway. And we have different communication styles here. We can have asynchronous communications or synchronous communications. For example, as a synchronous communication is that you can use REST. You can use RESTful web services and REST API. And for having async style of communication, you can use a message broker or even brokerless messaging system. But brokerless messaging system is not suggested because if you have mission critical messages, you may lose messages because there is no storage, there is no server for persisting messages. So in this case, it's not it is not suggested that you use brokerless messaging system like 0MQ or nano-MQ messaging system that you work with, for example, sockets. We suggest that you use a message broker like ActiveMQ, RabbitMQ, Kafka messaging system that is very good for using as a message broker. And here in architecture, it means that you can use any kind of technology. For example, different kind of programming languages for designing and implementing each services. One of them can be Java, another one .NET, another one Golang, and another one Python. And you can use client-side load balancing for having load balancing between services. You can use, for example, Netflix Ribbon load balancing system that is a client-side load balancing system. It's different from server-side load balancing system that you can implement, for example, using Nginx. So here you can have client-side load balancing system. In the future, may talk about more about client-side load balancing system like Netflix Ribbon. And here you may have, for example, Java and using JVM, Java Virtual Machine, as an execution environment, or another microservice you may have, for example, Erlang and using Erlang virtual machines. And in another microservice you may have, for example, .NET, and you may use .NET JIT just-in-time compiler and .NET BCL based class library, etc. for having .NET environment. And another one may be based on Golang, for example. As you see here in this Gartner view, each microservices can communicate with each other using different kind of communication style. For example, microservice A can communicate with microservice B using a REST API here. And also, if microservice A can communicate with microservice B, C, D using asynchronous messaging style using a message broker. We here have message channels based on EIP enterprise integration pattern. We have message channel here. It can be Kafka, RabbitMQ, or ActiveMQ, any kind of message broker here, that each microservice can publish or subscribe for message, and another microservice can publish and subscribe for messages that coming from the message broker. For example, microservice C only publish events to the messaging channel, and microservice B only subscribe to the messaging channel. But microservice A both publish and subscribe to the messaging channel. And here at the bottom layer of this outer architecture, we have operational capabilities of the systems for automation monitoring. For example, you can use Kubernetes, Docker Swarm, and or for any kind of infrastructure as a service or platform as a service like OpenShift, OpenStack, and Heroku. That may I talk more about infrastructure as a service and platform as a service in other part of the presentation. Okay, I think that is enough for this slide. Well, in this slide you see pivotal and cloud-friendly architecture. It seems complex, but I try to describe it with simple words and in a simple manner. Here at the middle of this part you see different kind of application framework that you can use in your microservice architecture. For example, you can use a Spring Boot, you can use Ruby on Rails, you can use Node.js, .NET. And here you see circuit breaker, that is one of the very important and very popular enterprise integration pattern, circuit breaker, that I will talk about it more in future. What is a circuit breaker actually? And here you can use RESTful API, or even you can use SOAP web services. SOAP web services that are based on WSDL, SOAP envelope, UDDI, and Disco protocol. And here you see 12 factors app. 12 factors is actually 12 principles for that. These principles can be used when you are designing applications, also distributed applications. One of them is configuration principle, that as I remember is the third one. According to the 12 factor, configuration of a platform of a system should not be in a single project. It should be separated, it should be available in the environment. And as you see here in microservice architecture, it is suggested that you use a configuration server. For example, if you use a Spring Cloud, you can use configuration server developed by Spring, by Pivotal. Or even you can use console server, console for distributed configuration, and also it can be used for service discovery. And here you see another kind of service for discovery. So you don't want that your services depends on each other. For example, one service depends on another service based on its port or IP in a static manner. You don't want to hardcode IP and port of another microservice in a specific microservice. So it is suggested that you use a discovery service. For example, you can use Eureka discovery service from Netflix, and also you can use routing services in your architecture. For example, you can use Zool as an intelligent and programmable routing system. You can use Zool, ZWL, and you can use container scheduling. For example, you can use Docker systems here. And here you have different kind of services: database, big data, continuous integration, continuous delivery. You can use, for example, Jenkins, Travis, TeamCity, Circle CI, Drone CI as continuous integration and delivery. Or for big data, you can use different kind of tools, platforms like Hadoop, MapReduce, Cloudera, RapidMiner, R language for big data. And in database layer, you can use different kind of databases. RDBMS like MySQL, Oracle, Postgres, SQL Server, or document store type of databases like MongoDB or Cassandra, or key value databases like Redis, etcd, Apache Giat, Redis Sentinel, or Spike, something like this kind of database. Or search engine databases like Elasticsearch or Solr, or graph databases that are using mostly in social networks, for example, Neo4j. And here, as operation, we can have different kind of operations. For example, for scaling of the system automatically, for having failover and recovery, also it can be automatically. Having zero downtime deployments, security patching, it can be also automatically, and platform upgrades. Here you see that as in the infrastructure layer, you can use OpenStack. OpenStack is a kind of infrastructure as a service. Infrastructure as a service is one of the categories in cloud computing. Other categories are platform as a service, and software as a service. Even you can have function as a service, and even science as a service. But if I type specifically about OpenStack as an infrastructure as a service, basically is some kind of cloud computing that provide virtualized computing resources over internet or over your local network. Infrastructure as a service like OpenStack is one of the main categories of cloud computing. As I told, platform as a service and software as a service are another kind of categories in cloud computing. And in an infrastructure as a service, you may have platform that is responsible for managing resources, hardware, software, servers, storage, and every kind of infrastructure components and resources. Also, you can use infrastructure as a service environment for having dynamic scalability. Also, you can use it for administrative tasks to be done automatically. And regarding PaaS, that stands for Platform as a Service, example, OpenShift from Red Hat is a platform as a service, or Heroku is a platform as a service. And what is actually is a platform as a service environment? Similar to infrastructure as a service, platform as a service is another category in cloud computing that allow users to develop, to test, manage, deploy, and operate their applications without messing with complex infrastructure.